Welcome to the Deep Dive. We cut through the noise, get straight to the insights. Today, we're looking at something lots of people think about AI in big companies, that it's all slow, maybe a bit overhyped. But what if there's another story? A really interesting, complex shift happening kind of behind the scenes. Our mission today is to unpack why these huge companies are moving away from just using, those ready-made closed AI models, and why they're taking on the tough job of building and tweaking their own open models inside their own walls. Okay, let's dig in.
Yeah, it's critical because, these enterprises, they have such massive reach, huge resources. So how fast they adopt AI really sets the pace for how this whole AI shift happens globally. And our perspective today, it comes from someone who's really been in the trenches. They sell foundational AI tools. They've talked to over 100 different enterprises in the last couple of years. Everyone from like Fortune 50 soft drink giants to big public software companies, and their core belief, maybe a bias, sure, is that the real AI value gets unlocked when companies build with it themselves, not just buying packaged solutions. Kind of like imagine if the tech world today only bought things like Salesforce and never built anything custom. It wouldn't be the same.
That's a really powerful analogy. It really draws the line, doesn't it? So let's trace this path enterprises have been on. Back in 2023, when models like OpenAI and Anthropic first really landed, well, what did that look like for big companies, the initial steps?
Well, initially, it was all about how easy they were to use, just incredibly simple to get started. So yeah, companies gravitated towards those closed frontier models. Makes sense. But unlike you or me just playing around, these guys deployed them properly in their own dedicated setups, Azure, AWS, mainly for security, privacy. And they usually tasked their existing ML teams, the predictive modeling folks, to basically figure out this new AI stuff and build on top of it. I actually remember hearing a CIO from this huge insurance company, he almost dismissed it, said their OpenAI setups were for engineers to toy around with.
Toy around with. Wow. That tells you a lot about the mindset then, doesn't it? Like not quite core strategy yet. So that was the early phase, just testing the waters. How quickly did things move beyond just toying around? What did 2024 look like?
Things changed pretty fast, actually. By 2024, based on the companies surveyed, something like 40, maybe 50% had actual production use cases, stuff running, doing real work, built on those closed models. So yeah, they were definitely getting more serious.
Okay, so a clear shift towards production. Now, heading into 2025, this is where it gets really interesting, right? People start seeing maybe some cracks in that initial plan, but maybe not for the reasons everyone assumes.
Exactly. It's really important to clear up some misconceptions about why they're shifting now. It's not mainly vendor lock-in. Yeah, it's consideration, but there are multiple big players now. OpenAI, Anthropic, Google, and there's some level of interoperability, like using OpenAI specs, for instance. So that's not the primary driver.
Okay, so not lock-in. What about cost? That's always a big one.
Well, last year, cost wasn't the main initial barrier people thought it might be. The thinking then was, oh, the price per token is falling off a cliff. This problem will just fix itself.
Right. And compliance, security, surely that's a factor for big enterprises.
Also not the main reasons for the shift away from closed models right now, because the big model providers, they actually handle a lot of that heavy lifting with the cloud platforms. They run models in dedicated VPCs, private setups, so those basics are pretty well covered.
Okay, so if it's not lock-in, not the initial cost worries, not basic security, what are the real reasons pushing them towards open source, towards building things in-house now?
It really boils down to, I'd say, 3 or 4 key things. First up, quality. But specifically quality for their specific use cases. These big general-purpose frontier models, they're amazing, but they're often not quite right for super specialized domain-specific tasks. Companies are realizing, hey, we have all this unique data. We can actually get better results if we train or fine-tune something ourselves.
Okay, can you give an example?
Sure. Think about a large health plan. They need to pull out very specific bits of info from millions of medical documents like CPT codes, diagnosis codes, prescription details. A generic model might struggle with that level of precision, but the health plan, they might have years of labeled data perfect for training a specialized model, or transcribing really niche medical jargon in, say, a doctor's voice note application. Again, specialization matters.
Got it. So precision, getting it exactly right for their world. That makes sense. What else?
Second big one. Latency. This is huge for anything real-time. Think AI voices on phone calls or interactive assistants. Latency is absolutely critical. We're talking time to first token. How fast does it start talking back and maybe time to first sentence?
Right. That awkward silence kills the experience.
Exactly. And the big frontier models, they're often optimized more for processing lots of requests at once, high throughput, not necessarily for that instant low latency response. So that becomes a real bottleneck.
Okay, quality and speed, what's next?
Yeah.
You mentioned cost earlier wasn't the initial driver, but has that changed?
It absolutely has. That's the third point. Unit economics and, frankly, ballooning costs. Remember that idea that costs would just sort themselves out? Well, that didn't quite happen, especially with the rise of what people are calling agentic use cases.
Agentic use cases, explain that a bit.
Sure. It's where AI isn't just answering one question, but it's orchestrating multiple steps, maybe calling other tools, having a whole back and forth to complete a complex task. So one click from a user might trigger like 50 or even more calls to the AI model behind the scenes.
Ah, okay, so the cost per call might be low, but suddenly you're making tons of calls.
Precisely. And those costs just explode. Enterprises are looking at the bills and thinking, hang on, maybe paying for our own compute power to run these models ourselves could actually be way cheaper than paying per token. It gives them control. They become, price makers in a sense, not just price takers.
Price makers, I like that. Control over the economics. Feels like a major turning point. Is there a final reason? Maybe something more strategic?
Yeah, the last one is a bit more vibey, maybe, but it's very real. It's strategic differentiation. Some people call it owning their AI destiny.
Yeah.
CTOs are starting to ask, if all our competitors are using the exact same off-the-shelf models from OpenAI or Anthropic, where's our edge? Where's our alpha?
Ah, the competitive advantage question.
Right. They want to differentiate not just with the app they build on top of the AI, but potentially with the AI capability itself. Bringing that core competency in-house becomes a strategic goal.
Okay, so this paints a clear picture. Quality needs, latency demands, cost explosions, and strategic differentiation are all pushing enterprises towards building in-house. But what does that actually mean? Moving from just calling an API to building and running this stuff, that sounds like a whole different ballgame. It can't be easy.
Oh, it's definitely not. This is where, as the source puts it, you encounter the real dragons, the hidden, complex challenges.
Dragons. Okay, tell us about these dragons. What's the first big one?
A massive one is performance optimization, specifically for latency. This is super involved, both at the model level and the infrastructure level. At the model level, you need serious expertise. You have to constantly track cutting-edge research, things like speculative decoding, Medusa heads, Eagle 3.
Whoa, okay, those sound complex. Eagle 3.
Yeah, it's a technique, a paper that came out maybe 6 months ago, and it's already running in production in some places, making a real difference in speed and efficiency. That's how fast this field moves.
6 months from paper to production. That's insane speed.
It is. And these aren't just settings you flip on. It requires deep understanding. Then, on the infrastructure side, you need optimizations like prefix caching or disaggregated serving.
Okay, technical terms again. Prefix caching. Disaggregated serving. What do those help with?
Prefix caching helps speed up responses when you have lots of prompts that start the same way, which is common in those agentic workflows. Disaggregated serving basically separates the expensive GPUs from the rest of the compute for better efficiency. These directly impact that time to first token we talked about, and also things like P99 reliability, making sure even the slower 1% of responses are still fast enough.
So just keeping up with the research to make the models fast enough is a huge task. It sounds like a full-time R&D effort almost. What about just keeping the lights on? Reliability.
That's dragon number 2, reliability and high availability. Getting to 4 nines of uptime 99.99% is incredibly hard with these systems. A basic setup might only get you 2 nines, maybe 99%. That sounds okay, but it can mean hours or even days of downtime per year for critical systems.
And what causes the downtime?
All sorts of things. Hardware fails. The underlying software frameworks, things like VLLM or Triton Inference Server, they can crash. And when that happens, those tail latencies, the slowest response times, they can just go through the roof. Users definitely notice that. So enterprises need to build sophisticated recovery systems, but without just throwing tons of extra hardware at it, because that kills your unit economics. That's a tough balancing act.
Okay, speed and reliability. What else? You mentioned traffic spikes earlier.
Yep, dragon number 3, rapid scalability. Handling sudden bursts of demand. I mentioned that soft drink company example. Taking 8 minutes to spin up a new copy, a replica of the same model when traffic surges.
Yeah, 8 minutes feels like an eternity if your service is suddenly getting hammered.
Totally unacceptable. You need systems that can scale up and down much, much faster.
It feels like the complexity just keeps layering on. Are there other hidden dragons?
Definitely. There's the whole area of developer velocity and operations, just making it easy or even possible for your own teams to build, deploy, manage, and update these models and applications. This means complex tooling, managing the whole life cycle, and really deep observability way beyond just looking at logs and basic metrics. You need to understand exactly what's happening inside the model and the infrastructure. And finally, for any big company, there are always enterprise-specific controls, meeting tough requirements for audits, compliance, security reviews, all that internal governance stuff. It adds another layer of complexity.
Wow. Okay. So we started with companies toying around with easy-to-use closed models. Then they realized they needed to own their AI destiny for quality, for cost control, for that competitive edge. But actually doing that means wrestling with these immense dragons, the deep technical complexities of performance, reliability, scale, operations, controls. It's a huge, huge undertaking.
It really is. And facing these dragons, it forces a really critical decision point for these enterprises. It boils down to, do we build this incredibly complex infrastructure ourselves, or do we buy it? And just to be clear, we're not talking about building the next giant foundational model like GPT-4. It's about building the sophisticated systems needed to run, fine-tune, and efficiently use various open models at scale.
Right, the enabling infrastructure. So that build or buy question feels central now. Given just how difficult managing these dragons sounds, how do you think most enterprises will ultimately go? Will we see specialized companies emerge, offering this deep infrastructure layer as a service, letting companies essentially buy their way out of the complexity so they can focus on their specific applications? Or will more and more large companies try to tackle these dragons head-on themselves? And what does either path mean for how quickly AI really permeates everything in the next few years?